Alright guys, we are back with another update. So I have the top frame pulled off here, as you can see. We're back to just the middle frame, but the middle frame is now resting on a traction loss frame. But first things first. So last time when I had the my legs, tight spaces. Last time when I had the middle frame on, I was going to size the connecting rods, which I did that here. And one good thing, you'll notice the connecting rods aren't the same size. That's one good thing about having multiple points. The motors aren't necessarily level on there. So in order to offset that, just had to cut and weld the connecting rods to their individual links, essentially. But next thing, since I moved the motors inboard like such, that means I had to move the connecting points to the frame inside, and I didn't have much room to work with, and I had to move them a little closer together than I wanted to. So when I had the full lever arms on here, they were basically, when they would rotate up, they would basically clip the connecting rods. So I just cut these off here and then grinded the top of them. I'll show you on this one. It's easier to move. Ow. So yeah, just grinded the edge off that and then cut that one off. And now it pretty much completely will rotate up and down without any sort of interference. And since I moved the motors so much further inboard, the range of movement on the roll is much more significant now. Much more significant. So that is a good thing, but it might possibly be a bad thing. This will be the first test of it, and so I'll need to see if the motors and the IBT2s and everything can handle it. I'm not sure if it's, moving them that far inward will just require too much torque and shut the motors off, or the motor drivers, or whatever. We'll cross that bridge when we get there. Okay, so we got that. Let's see here. Right, the motor brace built, the brace between the motors, so that way when they're like, say they're both trying to lift upwards, then it'll try and split the motors outwards, so that brace will stop that from happening. So now the motor should be rock solid. They're not going to move. Let's see. Right after I cut the connecting rods off, I had the remaining bit, the little overhang, the little part that I cut off, essentially, seemed like a perfect fit for being the surge connection mounting point. The problem was the hole in this piece here was significantly bigger than the diameter of the bolt. So I basically found a washer that would fit on the diameter of the bolt, and then I welded it onto that piece there, and then have that bolted onto that washer. So now I have the surge platform mounted. And then right behind it, the next thing. Sorry, I'm reading from a list and it's a little far away. The next thing I have is that both motors are now mounted. The block of wood is now mounted solid. The motors are in the position that I believe they should be in. All the connecting rods are mounted. Let me make sure I can get it good. So yeah, sled moves. I've got the center, the center piece, the center brace that mounts both trolleys together. I've got that welded, and then I've got the trolley wheels mounted and welded up. And one thing I wanted to show is the easy way that I always find to find out which way, like how to weld these swivel wheels and lock them into the position you need them in, is basically I'll have the platform like so, and then I'll put the wheel in whatever position. Like for this right here, I wanted both wheels to be on the outside because that'll give me more stability. If I had them reversed, then they would be a little more on the inside, and that would just not make it. It would want to tip more. So moved it towards the outside. Hello, Cocoa Face. I'm in the middle of something here. So moved it towards the outside, and then just roll it along the platform here, and then don't move it backwards at all. Just make sure, and if you do move it backwards slightly, just roll it forward. And even if you can, try and roll and weld a little bit, like weld. So basically, I'd start it like there, and then I'd pull it forward to make sure it's in the right position it needs to be, and then I'd start welding it, and then just kind of pull it a little bit as I'm welding it to make sure that it stays in the position it needs to be in. But basically, you pull it all the way through, and then you do the other one. Just this while you're welding this wheel can just be flopping around doing whatever it wants to do. But then you just do the other one, do the opposite thing on that side, and then just pull it and weld it, and then you'll know that they're welded into the exact position on the angle they need to be welded on. And there should be no binding or anything in there. So got the traction loss frame under there is significantly different than it used to be. It used to be 3 beams that came out in a triangle, and now it's just a T. It's still those 3 beams. One of them runs, you can see it right there, and it runs all the way up to the front. Whoop. Where it connects right there, I've only got one screw in there currently, as I'm just doing some testing. And then on the back, I've got the 2 2x4s that are just the cross beams for the wheels to ride on, and then the vertical mount over there. But the important thing was basically how I changed this mount here. When my initial plan was to reuse the little U mount that was underneath there. But when I started cutting it, I think I realized a little late that it wasn't steel, and I basically cut all the way through this, and then realized that there, wasn't throwing any sparks, and it wasn't steel, which means I'm not going to be able to weld to it. But I really, really did think it was steel, considering how heavy that the little rotating joint piece is. Ooh, almost fell there. This rotating joint piece over here is, considering how heavy that thing alone was, I thought that piece was steel, but it's not. It's aluminum, and those pieces over there are extremely light, which has made me think that I really need to learn how to TIG weld or weld aluminum, whatever that is. Just get into aluminum welding, because that stuff is stupid light. I'm just not sure if it's going to have the strength that I need for all this. Anyway, it doesn't matter. I had to remove that because it's aluminum, and can't weld to aluminum with MIG. So then I found a steel plate that was part of one of the brakes on the motors, like the back of the motors. They have like electronic brakes systems that go on there. That's just a steel plate that came off of it, welded it, I think I welded another washer that fit onto the bolt that goes, there's a bolt that goes through here, there's a bearing in there, and a bolt goes all the way through there. So I welded a washer onto that plate and then just welded the bolt, or bolted the bolt on there. And then I cut a hole out of the 2x4 to allow the bolt and the nut to sink into the 2x4. And then screwed that to the 2x4. And there really shouldn't be, there's not too much stress that's going to be on here except for, straight down into the ground. And that's, the wood's completely fine with that compression. That's not going to be an issue, and there really isn't going to be a terrible amount of stress on the traction loss frame, so it doesn't need to be terribly strong and triangulated and all that jazz. It really just needs to have the platform for the wheels to roll on, and then that platform needs to be connected to the U-joint up at the front, so it doesn't, when you pull on that right there, it doesn't move the entire frame. It moves this frame with the wheels, not the bottom frame. Okay, so then after that, we have the next big thing that probably doesn't come across in camera, but through all of these changes, like I said, the traction loss frame used to be vertical, 3 vertical 2x4s. Now they're all horizontal, and I changed these, the swivel wheels, the traction loss wheels, this style. Basically, all the changes has eliminated 6 inches of height from this mid frame. So the mid frame used to go to about the top of my calf, and now it goes to just above, I don't know, just above my ankle or something like that. So it is significantly, I don't know if that'll be able to get that in there. Yeah, so it's like without this other 2x4, it's like just above my ankle. So yeah, it's basically lost 6 inches of height, which is awesome, which means you don't have to step so high to get onto this frame. To then get inside of the top frame. So, and then lower to the ground just means that if there is an issue, that means you fall low, it's less of a distance to fall to the ground, and yeah, less torque, the less high that the weight is from its center of rotation, the less torque you're going to have when, especially on roll and all that jazz, all the physics and that. So, currently, last thing I'm doing is wiring everything up, and I'm trying to do the wiring somewhat fairly good this time, instead of how I had it before, where since nothing was moving, I could just, funnel all the wires to the front, and it was just a big rat's nest and didn't look good. Whereas now I can put it in a box and hide the rat's nest. It's still going to look like a rat's nest, just inside the box. So I've got the potentiometers, all 4 of the potentiometers are wired up. These ones have to be super long, and one thing I did find is at Home Depot there's this wire, this cable with two insulated wires and then one uninsulated wire, but it's still I just want to make sure that is that coming undone, you mother. So 2 insulated wires and one not insulated but still isolated wire. So I basically use those to wire up my potentiometers, since that keeps it all in a neat little package and gives me 3 wires, and it's just 5 volt, positive, negative, and then the signal wire doesn't need anything special. So this one's running here down through these 2 wheel supports, because they have like little channels, little holes. So we're on those, then this one and this one run under here, and then I'm going to attach all of it underneath this frame here. They're all running there, but they'll be underneath this frame here, and they'll run down into a box. And then I have these 2 potentiometers. I rewired this one to be much longer, it'll go down into the box, and then this one I ran out of this stuff here, because basically those two potentiometers took so much of it. And yeah, just basically took the wires that were on this one, attached them to this one, make them longer. And these ones have to be so long because this entire frame moves back and forth now because we have surge. And it'll move, I think, 7 inches, I want to say. That thing right there is 7 inches, so it'll move a total of 14 inches. But 7 inches from, I'll basically mount this to where this center is. Yeah, sorry about that. Stupid camera stopped recording. Okay, so yeah, this is 7 inches. So I'll basically set that in its center position, and then this box will set somewhere right around here, because if we move it in its full back position, then that's as far back as the wires will want to come from the potentiometers. And these ones, you know, are quite long. They can easily reach that side of the box from there. And I don't want to pull the box too far backwards because, again, the frame moves on traction loss, which means the further you go along this side rail, the more deviation there is, right? Almost no deviation up there because that's the point of rotation. Further back we go, more deviation. Get down. So we want to keep that box relatively at the front, because otherwise we would have to, you know, already if we keep it there, you can see how much the frame pulls away from the box, which I don't necessarily care about. I just don't want the box to ever hit the frame. So that is about it. We just need to get all the electronics in there, and then I need to add wire to these two motors, lengthen them. They're going to go there into the box, and then I'm thinking I'll probably have the battery somewhere up there, and then the battery charger next to it. And then all 8 of the IBT2s will go in there, because I'm doing parallels. Each motor gets parallel IBT2s. So it'll be 2 Arduinos, 8 IBT2s inside of the box, along with two fans. They're 24 volt fans, but I'll be running them off 12 volt, but they'll still be able to cool the IBT2s. Plus I'm running them in parallel, which means that they'll need half as much cooling essentially, because they'll be doing half as much work. But this is the latest and greatest update. So I'm thinking the next video I will be doing will be in the next couple days after I get everything wired. Definitely going to do some testing out here to make sure that the traction loss motor is powerful enough to move all of the frame. Make sure that the surge motor is powerful enough to move the frame back and forth. See how it works with my normal old car seat. That's where the cocoa went. See how that works with the normal car seats. I just want to see how, I don't want to change too many variables at once. I'm already adding the traction loss frame, and I move those 2 motors in. So want to see what the effects of that stuff is first, and then if everything looks good and it still looks like there's a surplus of power and everything feels great, then next step will be to try and possibly replace the car seat with that. But again, that's so heavy that I just don't think it's gonna work. But hopefully I just have tons of power and surplus, and then I put that on there. And again, since most of the weight's going to be over that U-joint, as long as the bearings would be able to hold it, which I don't think they are in the current configuration. I don't think in order for that to be able to go on there, I would have to rebuild the trolley. And I think I might already have to rebuild it, but we'll see. That's what testing's for, right? We'll see. Anyway, enough of my rambling. We'll talk to you guys later.